So good morning all. So actually we are end of the first unit. So we are almost done. So let me show you the syllabus. So by that we will start the second module. Right, guys, this is our syllabus. Okay. See, if you see the first module, so which is Introduction to Concrete Bridges. So you already gone through the introduction, history of bridges, types of bridges, components of bridge and its definitions, classification of bridges, isn't it? Selection of site and initial discussion process, how the survey and alignment is going to be done. So now I will try to show you what is the geotechnical investigations and interpretations and the economical span length of the bridge. Clear? So I think almost we have done the first unit. So we are going to start the second module today. So which is loads on bridges. So before starting this, let me show you what are the geotechnical investigations and what are the important things we have to consider for designing the bridges. Okay. Right. Yeah. See guys, in the internet, I have found some information regarding soil investigation for construction of bridges and culverts. Okay. So soil investigation in the sense, nothing but the geotechnical investigation only. So as we all know, before starting any kind of bridges, so one should, first go through the site. Yeah. And we have to take the soil samples. Okay. So soil samples in the sense, we have to go through the pit excavations. Okay. If you read out here, the construction of culverts or any bridges which requires a simple soil investigation. So why? Because culverts are very small span bridges, so which doesn't require a huge soil investigations. Okay, very small investigations are enough. So based on the type of foundation proposed, so the depth to which the investigation is going to be carried out is going to be decided by the engineer, right? So because foundation is a very crucial thing for the designing of the bridges. So by that, one has to go through the soil investigation very keenly. Okay, so which type of foundation is suitable? What is the soil bearing capacity? So what type of bridge is going to be recommendable at that particular location? So these are all going to be decided based on the soil investigation. Okay. So and one more thing, it involves with the planning about the level up to which the foundation is going to be taken. And anticipated velocity of the flowing water also is going to be considered for the designing of the bridges. So why? Because sometimes the soil may get score. Okay, for example, if you are constructing any bridge in the river, if the soil is get score, so the water will try to push the foundation also. Okay, so that definitely affects the whole bridge. Okay, understand? So by that, so definitely one should even anticipate the velocity of the flowing water during the floods. Okay, and the anticipation of any sort of deep scores, that also has to be identified. Why? Because due to huge velocities, due to huge floods, okay, along with the water, the soil, the silt or soil which is there in the water also will get a score. So along with that score, the foundation may also affect. Understand? So that also we have to be anticipated. Understand? And usually the pit is extended up to the rock. So wherever you do the foundations, usually what we do, we will go up to the hard strata, isn't it? And until you get the rock strata. Okay, nothing but hard strata, which is going to be available at this particular site. So if the soil cannot be considered as a hard strata up to a depth of 2 to 3 meters, you have to do the still more investigation is supposed to be done. So usually shallow foundation in the sense, usually we get shallow foundations within the depth of 2 to 3 meters from the ground level, right? So if you are not getting any hard strata within the 2 to 3 meters of the depth of the soil, definitely you have to go for extension. You have to extend your investigation and to achieve your hard strata. Understand? So these are very important soil investigations which you have to done before the construction of the, or we have before the designing of the bridges. Okay. So now let me show you what are the important bearing capacities of different soils. Now I request you guys, so please try to note down these, which are very, very important and which are to be considered for any kind of foundations. Okay, right. So see, type of rocks or the soils. Guys, if my screen is visible, under confusion the bearing capacity of soil. Akil, mute. Yeah. Guys, is the screen is visible? Under కనిపిస్తుందా bearing capacity of soil table?
Yes, sir.
Visible,
Right.
sir.
See, yeah. So please try to note down in your running notes type of rocks or the soils. First one is rock. So when we go for the rock foundations, so for deep soils, so definitely we will go for until you get the hard strata. So rocks usually will have different bearing capacities. So first, let me first give the clarity on the type of rock and its bearing capacity. First one is hard rock, so which is free from lamination and other defects. Examples: granite, basalt, and diorite. So if you found this kind of rock and the bearing capacity of this hardest rock is 3200 kg per square meters. So this is the hardest rock. Okay. So if you have this rock, so usually this is the bearing capacity. Based on this bearing capacity, you are going to decide also what is the load to be transferred on that particular foundation, isn't it? Okay. And next one, rocks that are laminated. Examples like limestone, sandstone, and sound condition. In particular sound condition, so bearing capacity will be 1600. See, these are very, very important even for competitive exams. They will give the example as a type of rock or type of soil, and they will ask you the safe bearing capacity values. Okay. So first priority we give for granite, basalt, and next one limestone and sandstone. And next one is the residual deposits of broken bedrocks like cemented materials, hard shales, etc., which will going to have 850 kg per square meters. And the soft rock and weathered rock will have 425 kg per meter squares. Okay. So these are related to rocks. And next one is non-cohesive soils. Okay. So non-cohesive soils will be something like sand, so which doesn't have any clay content in that. Like sand, gravel, so which is compact, which offers high resistance to penetration during the excavation. So which will have 425 kg per square meters. And compact and dry coarse sand will have 425, dry medium sand 250, sand gravel mixture or loose gravel will have 250. Okay. So these are the different bearing capacities of non-cohesive soils. And next one is cohesive soil, which is hard or stiff clay. Okay. So like a soft shale or deep in bed and dry unankondi. So usually if you go for foundations in river beds and all, so definitely you will have more clay content. So that's how you have to decide whether it is a cohesive soil or non-cohesive soil. And the cohesive soil which are having hard or stiff clay will have 425 kg per square meters. And medium clay, that is which is indented readily with the thumbnail. So nothing but if you insert your nail, even your nail will get inserted into the soil. So that type of clay will be cohesive soils, which will have only 200 kg per square meters. Okay. So based on these bearing capacities of soils, so one has to decide which type of foundation and which type of bridge can be recommendable at that particular location. Understand? So which is very, very important. Okay. And I will try to share this link to you guys, which gives even the hydraulic parameters investigation for construction of bridges and culverts. So I think we all seen these different hydraulic values and what data is to be recommended for the designing of the bridges and all. Okay. Right. Yeah. So next, finally, economic span of the bridge. So I think we have covered all the topics in the module 1. Okay. And I have shared you the notes also in PDF of all modules. Okay. Please try to go through even the notes also. Okay. And now we are going to start the module 2, which is loads on bridges. See, the second module is completely on different types of loads and its load combinations. Okay. So which is one of the important module to design the bridges based on the loads which are acting on the bridges. Okay, guys. Okay. So like, please try to focus on this module 2. So we are going to start it now. Guys, clear? So shall I move on to the module 2? Guys, please respond. Shall I move on to the module 2? Let me take the attendance once again. One second, let me take the attendance. Okay, I'm done with the attendance. Yeah, guys. Okay, now tell me, please, have you all satisfied with the module 1? So shall I move on to module 2? Guys, please respond. Just me respond avukapothe etla amma? Okay. So module 2. So which is loads on bridges and even the load combination also. So because one has to study what are the different types of loads which are acting on the bridges, and we can't design the bridge on an individual loads alone. Okay, so we have to go through with the load combinations. So that's why first we will study what are the loads on bridges, and next we'll go through what are the load combinations which are recommended by the code. Okay, right. So first, how you are going to study the loads which are acting on the bridges. So by that one has to give the recommendations. Okay, so loads on bridges are going to be recommended by code, which is called Indian Road Congress. Okay, so I think you all know about IRC, right? So you have to go through IRC 6 2000. Okay, IRC 6 2000, you have to download it. So now that code is going to show you all different types of loads which are acting on the bridge, along with the load combinations also. Okay, so please download this from the internet and please have a hard copy. Okay, guys, అర్థమవుతుందా? IRC 6 2000. Guys, clear? Please respond. Guys, మీరు వింటున్నారు లేదు నాకు తెలియాలి కదా, ప్లీజ్ రెస్పాండ్. If you're not responding, how can I continue?
Sir, వింటున్నాం sir.
Right. Okay, so please download this IRC 6 2000. Okay, so which gives the whole second module information. Okay, right. So basically this Indian Road Congress has formulated standard specifications, and based on the code of practice for road bridges with the loads and its specifications, and these specifications are collectively which are going to be known as bridge codes which are going to be known as bridge codes. Okay, so one has to know what are the different bridge codes which are available, okay, in the different sections. Okay, let me note down one by one. What are the Indian Road Congress bridge codes? So because if you go through the IRC 6 2000, you will find different bridge codes. Okay, so they are all defined in different sections. Okay, you are having total 8 sections. Each section is going to be defined with different standards. Okay, so that Indian Road Congress bridge code is the latest form which is going to be compressed with 8 sections. Okay, let me discuss one by one each section, and then you can able to understand what that section is particularly recommending. Okay, the first one is section 1. అంటే ఆ కోడ్ లో ఏముంటాయో చెప్తున్నాను ఫస్ట్. ఓకే, సో ఇన్ సెక్షన్ 1 you are going to have, it is going to deal with general features of design. Okay, so if you want to design your bridges, for that designing you will get some general features for the design. Okay, that used by the section 1. And next, section 2. So what this section 2 tells about? Section 2 will use the highlights of loads and stresses. So here it is. So the section 2 in IRC 6/2000 will give information about loads and its stresses. Okay. So that is what about section 2 in IRC 6/2000. And third one is section 3. So section 3 is going to talk about cement, concrete, nothing but TCC and RCC. Okay. So I mean to say, what are the different bridges based on a cement, concrete, plain and reinforcements. So that is going to talk about section 3. Okay. And next one, section 4. So section 4 will discuss about a brick, stone and block masonry. So if you want to construct any bridges with the bricks or stones or any masonries, so section 4 will use details about that. Okay. So one can download this IRC 6/2000, I mean Indian Road Congress 2000 will use all these different sections, okay, based on the different modules. Okay. Next one, section 5. So section 5 is talking about steel road bridges. Okay, guys. See here we will highlight which is the one important for your second module. Okay. So now section 5 is going to talk about steel road bridges. And next one, sixth one, section 6. Section 6 is going to talk about composite construction. Composite construction, right? And next one, section 7. Section 7 is about foundations and substructures. Foundations and substructures of bridges. Understand? Okay. So this is about section 7 and last final one, section 8. Section 8 is finally about the bearings. If you want to know about the different, what are the different types of bearings and what the bearings do. So what do you mean bearing? What the purpose of bearing? Purpose will bearings will transfer loads from super to substructure, isn't it? Okay. So that is the main purpose of section bearings, right? So this is what about the different types of bearings. So now one has to know which section is going to be used for your module 2. Tell me which section is going to be used for your module out of all these 8 sections. Emma, A section is important. Section 2 will give us information about loads and its stresses. Understand? Okay, so this we have to be highlighted. Okay, and please focus on this. So this you can download from IRC 6/2000. So basically Indian Road Congress, particularly for the bridges, is classified into 8 sections, in which section 2 is talking about loads and its stresses. Okay. Okay, Emma. Right. So now we will talk about so what are the different types of loads to be considered. So before that, how it is going to be calculated for what are the different definitions, everything we will discuss now. Okay, clear? So right. So now one has to know clearly. So all these above sections will, what information it gives? It gives the details in respect of the road bridges with respect to its preliminary data to be collected. Okay. So whatever data which you are going to collect as a preliminary data for the bridges, so based on that data, you are going to decide with the sections, and not only with the data, and even the clearances, discharges, foundations, all which are going to be very important. Okay. So that means, so the sections are going to be decided based on the few factors. What sections? IRC sections. Okay. These IRC sections are going to be decided or details with respect to the road bridges in terms of preliminary data. Okay, preliminary data which is collected, and clearances, and about the discharges and foundations, etc. Okay, so all these above sections will use the details in respect of the road bridges with respect to the preliminary data which is going to be collected prior to design of the bridges, and the clearances, discharges, foundations, etc. Okay, so and one more thing important, the codal provision undergo frequent changes, hence the reader is advised to familiarize himself with the latest amended forms. Definitely, whatever the sections which is recommending by the IRC code, don't expect that this is going to be permanent. So these sections may differ based on the data. Okay, sometimes these codes also will be redefined. Okay, they are going to be updated. Understand? So that also may happen. Okay, so don't expect that these codes are going to be permanent for the long period of time. Okay, that means, so definitely codes will always be revised based on the based on the reader, based on the data which you are going to collect from the sites. Okay, yeah, this is what about the Indian Road Congress bridge codes. Okay, and now we will have very important definition, so which is width of carriageway. Width of carriageway. What do you mean width of carriageway, Amma? So basically the width of carriageway will always depends on the, it always depends on how you are going to decide the width of carriageway. It depends on intensity, and it depends on volume of traffic. Ante kada, right? So the lane of the bridge or nothing but the width of carriageway is always depends on intensity of the vehicles and the volume of traffic. So which is going to be anticipated while using the bridges. Okay, bridge meda, what is the intensity of the vehicles and what is the volume of the traffic. Okay, based on that only the width of the carriageway is going to be decided. So usually it is always expressed in terms of traffic lanes. So Whitney, we are going to express in terms of traffic lane anta. Okay, width of carriageway. So we are going to express in terms of traffic lanes. So what is the minimum width of the carriageway? Anyone? What is the minimum width of the carriageway for a single lane?
3.75.
No, if you are going for the minimum width of carriageway for the bridges, it should be 4.25 meters. Please remember that. Okay, so this is for one lane, right? Which is recommending by IRC. Got it? So if you are going for two lane, so it will be 7.5 meters. This is for two lane. So please remember this. So this is what the Indian Road Congress is recommending for bridges. You are talking about for the roads. Okay. So road widths and the bridge carriageways are differ. Okay. So why? Because in bridges, so definitely there will be a footpath. Okay. There will be a lane track. So that's why the minimum carriageway for a single lane road is 4.25 meters, and the carriageway for two lane road will be 7.5 meters. Okay. If you want any for every additional lane, a minimum of 3.5 must be allowed. So now, as you said, if you want to go for another lane, okay, for the next lane, the minimum of 3.5 meter must be allowed. So nothing but what? If you want to go for three lane LL, then what they do? 7.5 plus 3.5. They won't add with 4.25. They will add with 3.5 meters. Understand? So that is how the lanes are going to be decided. Clear, Amma? Guys, andarki arthamainda? One lane road, I mean one lane carriageway width ante 4.25 meters. 2-lane carriageway width ante 7.5 meters. And next, if you want to go for any additional lane, okay, then you have to add 3.5 meters instead of 4.5 meters for getting the 3-lane. So, okay, which is recommending by IRC. Guys, these are very, very important for competitive exams. Okay, star mark petkondi and please note down them. Okay, 4.25, 7.5, and next additional lane to make it as a 3-lane, it will be 7.5 plus 3.5 meters. So minimum 3.5 meters must be allowed, okay, to make an additional lane. To make an additional lane. Okay, right? And next, for consideration of safety and effective utilization of carriageway. So what happens? It is desirable to provide footpath of at least 1.5 meter width on either side of the carriageway for all bridges. Okay, so this is also very, very important. Please note down, for safety and effective utilization. For safety and effective utilization, one has to add, okay, one has to add, I mean, to have provide footpath of at least 1.5 meter width on either side. On either side. Okay, so this is what about for safety and effective utilization of the road. Okay, this is what about the width of the carriageway. Understand, very, very important, A.M.I.E. What do you mean carriageway? What should be the minimum width of the carriageway for single lane, 2-lane, and 3-lane, or more than 2-lane? And if you want to have a safety and effective utilization of the road, one has to provide a footpath of either side 1.5 meter, okay, width on either side of the bridge. Okay, that gives your road as a safety and effective carriageway. Okay, so if you want, let me draw the diagram also clearly. So let us consider this road. Okay, so this is a single lane. So single lane means 4.25 meter. Okay, you can have a footpath on this side and this side. Okay, so you can make it as 1.5 meter, 1.5 meter as a footpath, and this carriageway will be 4.25 meter. Okay, so if you want to have a double lane road, so this is 1.5 meter and this is 1.5 meter. Center they will be divider. Okay, sorry, and this will be 7.5 meter. Okay, guys, so this will be for double lane road, right? So if you want an additional lane, so to make it as a 3-lane road, so definitely this will be 1.5, this will be 1.5. Okay, so let us consider this 2 lanes as 7.5 and this additional lane will be 3.5. Okay, overall it will be 7 plus 3, 10, 11 meters. 11 meters is the carriageway. Okay, double lane road. Clear? So this is 3-lane road. So this is what about different types of carriageways. Okay, so one has to know all these very keenly before deciding what type of road, or I mean what type of carriageway is to be decided for the bridges. Okay, clear? Right, guys, clear? Chapali. Then I will go with another topic. Very important, Amma. So sometimes they're gonna ask you how you define the width of carriageway. Okay, you have to write, then you can describe them in a pictures also like this. Okay.
Sir, clear, sir.
Right, very good. So now let's soon we will just discuss the heads, like what are the loads to be considered on the bridges. loads to be considered on the bridges. See, I think you're all familiar with the different types of loads. Why? Because you all designed RCC, right? Steel structures and all, because they're all related to buildings. So now let's see what are the loads to be considered on the bridges alone. Okay. So, while designing road bridges or culverts, so one has to follow different loads, forces, and stresses which are going to be considered. And so here, when you are designing your bridges or any culverts, you have to consider three important things. One is loads. The other one is forces. The other one is stresses. Okay. Don't expect that there will be always a four loads. In buildings, there will be loads. But when it comes to bridges, so if you see any road like this, so this is a straight line road. And this is the curved road. Okay. So here there will be a load. Here there will be, here there will be force. What type of force you can get in curvatures? A force untundamma ikkada. You will have a centrifugal force. Antena? Right? So let's see any other road which is subjected to high temperatures due to weather. Weather ఉన్నప్పుడు ఏం స్ట్రెసెస్ ఉంటాయమ్మా వీటి మీద? వీటి మీద ఉండేది ఏంటి? Due to temperatures, due to weathering conditions, there will be stresses. So when you want to design your bridges for different conditions, there will be loads on bridges, there will be forces on bridges, and there will be even stresses on the bridges also. Understand? So now we are going to list out all these loads, forces, and stresses in very clear manner. Okay, right? So let me write down what are the loads first. Cheppandi, loads eme untai. First one, there will be a dead load, which we call it as a self weight, and next one is live load, and the third one is snow load, and fourth one is impact, or it can also be called as a dynamic effect, due to how this impact or dynamic effect will fall on the road. దేని వల్ల వస్తుందమ్మా ఇంపాక్ట్నెస్ ఆర్ డైనమిక్ ఎఫెక్ట్ ఆన్ ద బ్రిడ్జెస్? ఎవరన్నా? How the impact load will affect on the bridges? What type of load can be considered as an impact load? Due to what? Due to vehicles. Okay, so when vehicle hits the bridges, there will be sudden accidents which happens on the bridges that will create impact or dynamic effect on the bridges. Okay, this happens due to vehicles. Okay, and next one is wind load. Okay, next one is longitudinal force, which is caused by how the longitudinal force will occur. Longitudinal force will occur by braking of vehicles. So when vehicles applies brakes on roads, on bridges, especially on bridges, that braking will use the longitudinal force to the bridge. Okay, it is not a load, it is a force. Clear? So why? Because these are only loads. Ikkada varaku unnavi loads: dead load, live load, snow load, impact load, and wind load. Okay, now we are talking about forces. Okay, one is a longitudinal force. Longitudinal force will cause due to braking of vehicles. Okay, vehicles which applies brake, when it applies brake. Okay, and next one, longitudinal force, again longitudinal force due to frictional resistance. of expansion bearings. Okay, there will be again a longitudinal force which is due to frictional resistance of expansion bearings. Okay, and next one, centrifugal force. So how the centrifugal force will occur? Centrifugal force will occur due to what, Amma? Due to curvature. And next one, horizontal force. What do you mean horizontal force? This horizontal force is due to what? Due to water currents. Water currents in the sense due to wave action. Okay, so these all are forces. Okay, please note down: dead load, live load, snow load, impacts or dynamic effects, or wind load are comes under loads which are acting on the bridges. Longitudinal force due to braking of vehicles, longitudinal force due to frictional resistance, centrifugal force due to curvature, horizontal force due to water current. These are all forces. Okay,